Hi there. So this is going to be a very short video discussing the center of mass equation and where that comes from in terms of torques. So we're going to think about a very simple system where we have two masses, m1 and m2, which are connected by a rigid rod. We don't need to worry about the mass of the rod itself, just the masses. Okay, so what can we do? Well, let's start off by writing down what forces these things will be subject to. So there will be a force, let's call this F1, which is going to be equal to m1 times g. And we'll also have a force on this second mass, which we'll call F2, and that will be m2 times g. Okay, now one of the key things here is a key idea to think about is how would you find the center of mass experimentally? The way you can do this, if you had some sort of object in your hands, is you take your hand, you would try and find the point for which it doesn't fall off of your hand. So, for example, with a pen, you would do something like this until you could get it to sort of stay on your fingers. Mathematically, what that means, or in this picture, is we're going to try and find the point here, which we're going to call, we need a unit system here. So let's define this to be the x-axis. We'll call this x equals 0. We want to find the point xc, the center of mass of the system. Okay, we need to write down some equations and set ourselves up. So the first thing to do is to work out the torques that are going to be acting on this system. So the torque, in general, is given by this. It's a vector quantity which says r cross f. Okay, so we're going to have two torques. We're going to have torque 1 and torque 2. But in which direction do they act? Well, we have to think about what r is here. So r is the vector which joins x, the center of mass, to the mass. So it goes something like this. And it will also have a direction. It will come from that center. So r will, in this case, be going in this direction, whereas for torque 2, it'll be going in that direction there. So which direction does the torque lie in? Well, we can use our right-hand rule. So we take our right hand, we put, so for m1, the r is in this direction, the force is downwards, so that means my thumb is pointing towards me, that the torque will be coming into this, out of the plane in this direction here. Whereas for torque 2, well, okay, the same story, I put r along this direction, then the force is acting downwards, and my thumb points into your screen, and so the torque is going in this direction. What this means is that the torques are in opposite directions, okay? So what does that mean? Well, if we want this system to be in a torque balance, then what we need to say is that the torque 1 is equal to minus torque 2, okay, as vectors. So what that means is that we want the sum of them to be equal to 0. Okay, well, we actually don't need to worry too much about the vector quantities here. We can take just the magnitudes, and so we can take the magnitude of these two things. We'll do this. And we can then see, okay, well, r cross f. Well, r cross f is the magnitude of r times the magnitude of f times the sine of the angle between them. Well, you can see that if this thing is balanced, then that angle will be 90 degrees. And so the cross product here simplifies to just r times f. Okay, so what do we have? Well, we have r1 times f1 is equal to r2 times f2. Okay, now we can start to put in some things. So we could put in the f1 and f2 quite easily. We've already written them down. But what exactly are r1 and r2? Well, those are the lengths of these distances here and here. Okay, so we now need to be a little bit careful to set up exactly where these are. So what I'll do is I'll give this a position. I'll say this is x1. In fact, it doesn't matter so much whether we define this to be 0 or not, so I'm just going to remove that. And I'm going to say this is x2. Okay, so in general, this is just the x-axis. This is where x1 is, and this is where x2 is. Okay, r in that instance is xc minus x1. Like that. F1, well, that was just m1g. When r2, Well, R2 is now x2 minus xc. You have to be careful with the signs here to get these the right way around. x2 minus xc, and of course f2 was m2 times g. Okay, now we have an expression which has all of the things in it that we want, so we can see that the g's are going to cancel. But exactly what are we after? Well, we're after this xc, and it's tied up in all of these in these two terms here. So what I'm going to do is I'm going to simplify this a little bit. I'm going to divide through by m1, and then I'm going to collect the terms of xc on one side. So what will I have? Well, I'll have xc here, and that will be, well, no, let's keep this, let's try and do this step by step. That will be xc minus x1 is equal to m2 over m1 times x2 minus m2 over m1 times xc. Okay, now I can, of course, collect those xc's on one side. So I'll have xc, well, I'll pull out a factor of 1 from here, plus m2 over m1 from this term here, and that will be equal to m2 over m1 times x2 plus x1. Okay, now we need to, of course, simplify this again. So what we want is just xc by itself is equal to something. So to do that, let's start off just writing down the left-hand side. That's the easy part. Well, okay, now I need to simplify this term here. Let's actually do that in this step. So I'll multiply through by m1 top and bottom here. That will give me m1 plus m2. And that will be all divided by m1. And that will be equal to, well, the same thing here. Okay, now I'm running out of room here, so I'm just going to skip over to here. And what I'll find eventually, so if I multiply this term up, I will have 1 over m1 plus m2. Okay, so that comes from this term here dividing through, and I multiply up by m1, so I'm going to have m2, well, let's write this in order, m1 x1 plus m2 x2. Okay, so maybe go through that by yourself if I went through a little bit too quickly, but what you'll see is we have arrived at this equation for the center of mass as being 1 over the total mass times m1 x1 plus m2 x2 by simply starting off with the torques in the system. It's worth having a play with this and familiarizing yourself, and it does generalize to having any number of discrete masses, of course.